like walk.
All right, we'll get things rolling. We were going to have a here in person today, as I indicated, but with the nasty weather, it was just not worth the risk of driving down to Charlottesville. But the good thing about it, her being in Charlottesville, is if you like what she's got to talk about today, it's not an awfully long drive to go see what they're doing in person and see what they're up to. So this is Ruby Zielinksi. She is the project manager or research manager for the Natural Infrastructure Lab up at UVA, who's kind of headed by Brian Davis, one of the faculty there. And I'm super excited about this one because Ruby is one of like my favorite kind of young designers at the moment. Just seeing what she's up to and the few opportunities I've had to talk with her, it's like just brings a lot of energy to kind of everything. And I think you'll all get a really kind of good kind of kick and get good value about what she's got to share. So she did a Bachelor of Fine Arts at the Memphis School of Design, later worked on the Memphis kind of riverfront project, doing some of the graphic design work there, which kind of got her hooked on the idea of landscape architecture. And then went and did a MLA at the Bartlett School in England. Very, very nice. Very interesting program over there. And then came back to the US and then started working with Brian and team at the Natural Infrastructure Lab at UVA. And it's that work that they've been doing as a kind of research collective, and they're kind of aligned with the folks at Auburn and Brett Milligan over in California. So it's a really nice kind of like collective research approach to this kind of like tidelands, coastal lands, dredge way of working in landscape architecture. So I'm going to hand it over to you now, Ruby, and you can take us away.
Thanks, Sean. That was so kind. Hi, everybody. I'm sorry that I'm not there with you. But yeah, we've got quite a bit of snow on the ground, and I'm a weenie when it comes to that. So I was grateful that Sean adjusted and was flexible to this. So yeah, I'm just going to kind of jump right in. I'm going to repeat a few of those things that Sean just talked about to give you a good introduction into kind of like the Natural Infrastructure Lab and a little bit of my background and context. And then we'll talk about Tidelands. Okay, let's see. Can everybody see that?
Yep.
Great. Awesome. I'm going to do a split screen so I can at least see some of you guys. Okay. Good. Great. So I've broken up this lecture a little bit to have a few pauses in to ask if anybody has any questions, because there's kind of like 3 sections to this naturally. So I encourage you to speak up. This is a safe space, and there's no stupid questions. I know people say that and then you feel like you still have a stupid question, but I really do mean that. Please ask and engage with the work. And if there's anything I can do to help, I'll do it. So hi, I'm Ruby Zielinksi, and I manage the Natural Infrastructure Lab here at the A School at the University of Virginia. We work to develop innovative natural infrastructure that enhances human and ecological health over time. But that's a little buzzwordy. So what does that really mean? So we kind of define natural infrastructure as working with the processes, forms, and materials of a place, its nature, for infrastructure purposes. So one of our co-directors that Sean mentioned, Brian Davis, likes to say that even beyond pressures of development, one thing that our society has consistently agreed upon is the need for innovation in infrastructure, especially water infrastructure. And the practice of landscape architecture has a natural place in this area of research and application. So there's technological approaches that already exist, but nature provides many more models that we can learn from. So that's kind of our goal, is to learn from nature and create new innovative forms of infrastructure. And so this has been proven through many years of partnerships with the Corps of Engineers in coastal systems throughout the country. And we've collaborated with practicing landscape architects, engineers, federal agencies, environmental nonprofits, and other universities to do that. Alongside these reports, we have a handful of structures that have been built through the Healthy Port Futures Initiative and a partnership with the National Park Service called Preserving Coastal Parklands. So the team is pretty small. We're small but mighty is what I like to say. We expand and contract as different projects come in. We're led again by Brian Davis, who works across teaching, research, and practice. And each of us brings a different lens to look through, hopefully making the work stronger and challenging each other to think differently and ask questions that we wouldn't otherwise ask. So Sean alluded to this, but my context comes from this mystical, muddy place. I was fortunate enough to call the Mississippi River my office for several years while I worked for the Memphis River Parks Partnership, as we took on creating kind of a new vision for Memphis's riverfront. My lens is made up of these pieces. My background is in art and design. I'm a graphic designer by trade, but my experience with working with the parks widened into programming and events, community engagement, fundraising, and park operations. I went from being the graphic designer to a year later running the brand experience of the park, which encompassed the operations and maintenance of 250 acres between the river and the city. But I was lucky enough to be there at the beginning of Tom Lee Park's transition. If you're not familiar with that project, I highly suggest a quick Google search. And working with Studio Gang and Scape inspired a shift into landscape architecture. So after graduating from the Bartlett with my MLA, I came to work with Brian here at NIL to explore more mystical, muddy places. And so we call those Tidelands. And today I'm going to talk through kind of this research project, which is our biggest endeavor to date, encompassing kind of the largest geographic scope that we have yet to focus on. I'll go over like a bit of context, and then we'll dive into a particular site, hopefully giving you a glimpse into our design research process. As Sean also mentioned, we're not alone in this. So Tidelands is a collaboration between us, UPenn, and Auburn. And these partnerships were formed out of the collaborative effort called the Dredge Research Collaborative. And in this way, we were able to cover more ground and collaborate across geographies and skill sets. Each lab within the respective universities has different superpowers that we kind of take advantage of as we tackle these challenging questions. At the beginning of the project, the scope was pretty open. So there weren't specific sites that we were given to work on. In order to narrow down kind of where we wanted to work or were going to work, we hosted a workshop with stakeholders that included coastal ecologists and geologists, environmental nonprofits, engineers, landscape architects, and more to help us figure out kind of where to start. And also to kind of define goals and different criteria for site selection. That led to a larger classification of the two coasts, which was built by the team at Auburn. They're kind of our like mapping wizards. And so 32 units from Maine to Texas are categorized according to different features. And so by situating our work across a range of regional landscape units, we can ensure that our design approaches reflect the diversity of estuary conditions across the Atlantic and Gulf coasts. And thinking through units also supports the potential for design strategy transferability between sites. So across the three universities, we chose a handful of units that we would focus on, UPenn taking kind of the North Atlantic, Auburn taking the South Atlantic and the Gulf, and then we took on the middle. So we were put on the trail of the North Carolina coast by one of our partners who worked for the Fish and Wildlife Service at the time. His name was Fred Worster. He's actually pictured in the kind of like Point Peter image, like in the middle on the right-hand side there, talking me through what this like peat coast is and how it kind of like calves off into the water. But he sent us a map of these projects that the Fish and Wildlife Service was looking at to apply nature-based solutions to. And so the team, mainly me and my colleague Adrian, packed up and we spent a week surveying sites and meeting with National Wildlife Refuge folks to find out where to work. So we went to 8 sites in 5 days, trying to learn about this place to get a sense of where we could possibly make an impact. And I wanted to share this kind of method, but one of the things we use to kind of help us out in the field is like a booklet field guide. And this helps us navigate different dynamics and details that we might need without having to be on our phones, and likely in places that don't have a lot of service to begin with. So these booklets give us a way to make notes, sketch ideas, and also catalog observations in real time using maps and data that are collected like before we go out into the field. So when we came back from that site visit, we collected that information in these one-page snapshots of each place to capture the knowledge that we gained and also develop a way to kind of narrow down site selection. But you can see like there's quite a bit of rigor in what we were collecting. And yeah, each site had its own kind of like catalog like this. In the end, we landed on these 3 wildlife refuges: Mackay Island, Alligator River, and Pea Island. And these sites had already kind of began to ask questions about the future and also possessed challenging pressures for ideas that needed to kind of happen now. And so I figure it would be helpful to kind of walk through one of these. We like sent suggestions for all 3, but might be good to like dive into one. But this is one of those points where I'm going to stop real quick because I've talked a lot about kind of context. Does anybody have questions about larger context or the project in general before I keep going? Give people a second. Take a sip of water. Okay, we'll just keep powering through. So today I'm going to talk about Mackay Island, which is my favorite of the 3. But it's kind of a really strange place, and hopefully you'll see why. So Mackay Island holds an interesting history, as many of our national wildlife refuges do. This one centers around the sport of duck hunting. And I don't know if you guys are familiar with like the Ducks Unlimited folks, but Joseph Knapp is one of the founders of Ducks Unlimited. And this was his estate on the island where he would spend a lot of time away from his busy life in New York City. Knapp and his hunting friends shaped the island in different ways to create a haven for ducks. Ponds were created using fences. Land was pushed up along the shore to create little bays and larger water bodies. And ditches were cut through using dynamite to allow for access to different parts of the island. And you can see some of that here. Can you see my mouse? Cool. So these kind of lighter sections here in this aerial show kind of like where they had like pushed up land to create these kind of like bayed areas and like make this kind of, this is not really a natural shape, right? You can kind of like tell that it's kind of human made. This is like a fence line that they created to kind of enclose this area. And then these like straight lines through the marsh are those kind of like dynamite trails or areas that they would kind of like bulldoze through so that they could get into the like nooks and crannies of the island. But really changing kind of like the nature of this place. So the Fish and Wildlife Service took over management of the island in 1961, 10 years after Knapp's death and after a logging company kind of went belly up. The priority shifted from hunting to habitat in order to understand kind of like how the operations changed. We dug into these old narrative reports that the refuge managers created from 1961 to 1980. And they're like fascinating and actually quite funny. People didn't have spell check and like, you know, AI to write things back then. So it's all very stream of conscious and quite charming. But in these, we discovered how the refuge created access to different parts of the island, not by dynamite, but by digging channels and berming up land to make roads. And by doing this, they created some enclosed ponds that later became bird impoundments. So bird impoundments, if you're not familiar, are essentially kind of these controlled freshwater ponds that the refuge can control the water levels in order to attract and cater to different migratory waterfowl throughout the year. And then we were looking at kind of some of these old historic maps. and came across old channels and infrastructure that have since disappeared. But these artifacts were kind of confirming what we had been told by the refuge staff, as well as some like early assumptions that we had about the hydrology of the island. So here's a view of the island today. You can see the impoundments are here, those kind of enclosed ponds, much more like geometric in shape than some of the other things. There's kind of a refuge road that kind of cuts through the marsh here, which is like a much smaller kind of like local traffic kind of road. And then there's a big causeway that cuts through the marsh here along the north side. There's a very, very small kind of agricultural community that they call Knott's Island here on the east side. And then a fun fact is, so the Atlantic Ocean is here and the coast of North Carolina is here. You can see that like strip of beach along the edge. But this used to be an inlet, and that's what created like all of these little marshy islands here. But anyway, just kind of a fun geomorphological feature that was left. But all these alterations and all these kind of like diggings that led to all these little findings have kind of led to a lot of challenges that the management team faces today that kind of like are on the refuge. One of those, which you might have noticed, is this big ditch, which they call Corey's Ditch. And it's a mile long, cutting straight through the marsh north to south. This is one of the ones that they used dynamite to create. The ditch started about 20 feet wide and now sits about 100 feet wide due to erosion. And it's caused a serious imbalance in the hydrology over time, creating poor drainage and resulting in the marsh drowning throughout the island. So from past to present, we started looking into how the refuge was operating today, what natural forces were present, management routines, visitor information, migration data, and crop information, as some areas of the island were portioned off for agriculture. But drawings like this help us put these different data sets in concert with one another, shedding light on the relationship between them. We also looked at how the island had changed over time, where the marsh was drowning quickest, and which areas would become water first. And so we use a model called SLAM, or Sea Level Affecting Marshes model. And this takes into consideration the diversity of marsh units and uses different accretion and erosion rates to give a more accurate prediction than a simple bathtub-based model. And then the still images of the island's change over time are mapped using old historic aerials, current GIS data, and those SLAM outputs. So the SLAM model showed us that the large pools at the northwest corner, these little guys here, we're going to get a lot bigger. And we noticed that the east side of the marsh, this kind of area here, would stay healthier for longer, or at least it didn't turn into open water as fast as the west side adjacent to Corey's Ditch, which is this kind of straight line here, just to orient you. And we also looked at the unvegetated to vegetated ratio. This is a tool from USGS that shows which areas are more vegetated than others, which also indicated that the east side had kind of a healthier vegetated ratio than the areas directly next to the large pools, which are those like hot pink areas. It's very wicked looking, but maybe that's just where my frame of mind is at right now. And so here we are looking at the natural forces acting in and around Mackay, analyzing the amount of fetch or water runway, wave action, and the flow of water during storm events. One of the original reasons we focused on Mackay was that it's a critical storm dampener for the south end of Virginia Beach. So Mackay Island sits kind of like here in these three images, and Virginia Beach kind of sits like the Back Bay kind of goes up along here. There's a resort community called Sandbridge, and then Virginia Beach proper is kind of like right up here. And so the thought was that if Mackay Island drowns, the amount of fetch, so the length of like potential water energy would double, creating like a lot more energy that would hit kind of the south end of Virginia Beach on the bay side. So to study these natural forces, we also use hydrodynamic modeling and programs like CMS Wave and Flow. These are tools developed by the Corps of Engineers to study wave and water patterns. And here you can see we've kind of plopped in some relatively random shapes and raised our elevations using Rhino. And then we input those into CMS to see how different landforms would affect the flow of water during a storm event. The darker areas here are like higher energy. They're actually like little tiny arrows, but it's kind of hard to see in this context, so you have to like zoom in. And so while these are relatively ambiguous, they tell us a story of water movement and allow us to iterate dynamically with the physics. So while these models aren't used for final permitting, they allow us to sketch ideas and artistically represent the forces at play in these places. And we use these tools to try and learn the language of adjacent fields. So models from the engineering world, data from the science spheres, to be the mediators that Smithson describes here between art, ecology, and industry, the unique position of what I think of a landscape architect. Alongside the modeling, our research incorporates rigorous precedent studies from projects rooted in landscape architecture and engineering, as well as adaptive management and land art. I'm often referring to people like Noguchi and Nancy Holt, always trying to kind of bring more artists into the conversation. One of the reasons that we were looking at woody precedents, you can see some of those kind of like here, was due to Fred's interest in brushwood fences and beaver dam analogs. He installed one as an experiment on Mackay Island in March this year, hoping to protect a small bit of eroding shoreline and capture sediment. And we're supporting this effort by helping survey any changes. Still, like March is still like pretty recent, so we don't have like a huge amount of data yet, but we're continuing to kind of like monitor, try and make sense of what's happening. While we do a lot of digital modeling and desktop research, we also do quite a bit of physical modeling. We have a large wave basin in the lab, which is this giant thing behind me, where we can test some of these ideas with real materials and water. And this is a very qualitative approach to modeling to see how materials interact and deepen our intuition with the kind of different forces at play. In a more conventional project, we would conduct community engagement with people that lived kind of near the places that we're designing. But in this case, we dove into the refuge's bird communities to ask questions and understand their needs to anticipate ways we could kind of enhance our proposals to welcome these feathered friends of ours. But some of the questions that we asked were like, what qualities are you looking for in a home? And this kind of like gets at questions about like, what is their nest type and like, where do they like to nest in kind of a playful way. Another one of the questions is like, what conditions are best for you to get together with your friends and family? But this was kind of focused on like social behavior and gathering, also in a very playful way. But I mean, these are questions you would ask people if you were designing a park or something, you know, next to their home. And in this case, we were just talking to birds, hypothetically. We also invite experts into the lab for design workshops. And here we have a geomorphologist, hydrologist, and coastal ecologist to bolster design ideas, but also to kind of like bust our assumptions. It's kind of like having like a big desk crit with these like experts in the field. But again, just bringing in expertise from other fields and trying to learn how our ideas are impacting the dynamics of this landscape. So these explorations led us to break down the island into 3 different zones. Zone 1 and 3 are fairly similar in character, but have different challenges. And then zone 2 is mainly that marsh that takes up the largest area of Mackay. But we like to go through this exercise that we call IPQI, which is like a terrible name, but it's like the only way to do it, at least so far. Unless if you have a better idea, please let me know. I'm looking for new ways of categorizing this, but it's mainly just a way for us to move through the design research process. It's kind of like a loose scientific method for developing design strategies that kind of summarize a lot of our investigations. So the issues for each zone are mapped to a specific problem, leading to a design question answered by a concept or hypothesis. Then implications were built based on our research, drawing, and modeling. And these questions and implications change throughout the process depending on new information, busted assumptions, model results, or kind of like a simple shift in intuition. So all of this together led to several design propositions, some able to be conducted by the refuge themselves, some more intensive, and some longer term ideas that would require more resources. And I figured I'm going to run through some of the suggestions so you can see maybe how some of that process led into design. But before I do, I'm going to pause one more time because I know I just like fed a lot of information your way. So are there any questions at this point about kind of the process, drawing, modeling, field work, etc.? We can also talk about that after, but in case there's anything jumping.
Ruby, can I ask a quick question?
Please.
Back of the slide. One of the design solutions that you were testing was Phragmites, which is an invasive species. Can you talk about kind of what your ethics were behind that and kind of how you use it?
Totally. Oh, I love that you brought up frag. I'm so happy you brought up frag. It started out as something like relatively playful that Adrian and I were kind of talking about because there's just so much out there and the management of it is so difficult, except actually in the impoundments. The refuge manager here had figured out a way that he could kind of like play with water level to like discourage it from growing and like cutting it at a certain time. He was like almost like farming frag, but in a way that it was like keeping the management of it really low so that they could have things that they actually wanted. So that kind of like got us kicked off in thinking like, is there a way to actually use this? Because so far it doesn't feel like there is a way at a large scale to manage it completely. And so I guess in terms of like ethics, it's hard because it's like, well, while we're not suggesting planting it and like we're not suggesting encouraging it, but if it's going to be there, maybe we could find a use for it in some way. And so in that kind of like relatively playful question, we were looking at maybe ways of like doing the brushwood fences, but using frag, since it's like a readily available material that's like, I don't know, it's inevitably going to grow, I guess, or things like that. I don't know if that answers your question, but it was kind of like a design proposition that came out of a relatively playful curiosity, I guess.
Thank you.
Yeah, thanks for the question. We had so many weird drawings about frag. There's like a lot of trace paper with like these like silly little fences and strange shapes and alliterative kind of like titles about frag farms, but none of it kind of like came to fruition because like at the end of the day, like it is kind of a disaster. Anybody else? Okay, we'll dig into design. So the North Bays have kind of a simple move using the brushwood fence method and echoing some of the historic infrastructure that existed during Knapp's time on the island. Given the issues in the North Bays, we suggested putting brushwood fences along the historic duck pond fencing. So I don't know if you remember that historic aerial, but there was that kind of fencing here that cut off this kind of boot area. So sometimes, especially for permitting and things like that, it's easier to follow a line that already exists or some sort of like historic boundary. And so we were kind of like following that historic boundary, but just using kind of a new innovative method. And these fences would lower water turbidity, and turbidity is kind of like water clarity, encouraging submerged aquatic vegetation, or what I'll later call SAV, in this area, which is great for carbon sequestration, underwater habitats, and also slowing waves. We also knew from the refuge manager that submerged aquatic vegetation grows actually really well in these areas, but unfortunately it kind of gets cut off at the knees, I guess, in some way because of bass fishing and just like general kind of like water activity. And so one of the strategies as well, or one of the added strategies, is that this area could kind of be kept away from boat activity, or at least like boat motor activity, and create kind of a lower energy area for SAV to kind of like have the opportunity to thrive. But it's not something like, in a lot of places, people are having to plant SAV or like create habitat for SAV. These places actually are already good for SAV. We're just kind of like giving it the boundaries that it kind of needs in order to grow. The cool thing is for these brushwood fences that the materials are pretty cheap, and a lot of them can be gathered from the refuge itself. So when we visited in February, before Fred installed the fence in March, he had kind of like collected all of these bundles of brush clippings from around the island. But just a really kind of like beautiful, but like rough way of creating this fence. So the fences mimic some of the precedents that we found in places like the Netherlands, but are adjusted to a microtidal environment. The width and the length are really similar, just to make sure that they're kind of like able to be built in a kind of lo-fi way. But we adjusted the height to better accommodate kind of like the more subtle water level changes. As far as zone 2, this is the largest zone and most complex, as the hydrology was still a bit of a mystery even to our expert geomorphologists. So here we aimed to protect the area or areas that seemed to naturally last a little longer, and add in a few habitat spectrums inspired by other areas of the island, while sacrificing some areas that are already too far gone. And so this is done through kind of this big cut and fill strategy, which aims to use a lot of the material from the place. And we think that deepening the existing ponds will encourage new underwater habitat and support SAV growth, as it needs kind of like a certain depth to really thrive. And so this would be like new SAV. This would be like creating new habitat. And while the fill areas are quite large, they don't go up very high. So we don't want to change the character of this place too much, but we want to encourage better drainage and water movement in kind of a subtle way. And we tried to stay within the threshold of acceptable like thin layer placement practices, which is about 2 feet. And we're strategic about where we suggested going over that. But these kind of drawings show just the dynamics, I guess, of the change that's happening and kind of proposed higher elevations and things like that. As you saw from those kind of narrative reports, the moving of Earth has been something that the refuge has been doing since 1961. So many of the suggestions that we are making would allow for the refuge to do much of the work themselves, knowing that the makeup is like mostly peaty soil. We knew that like these built up areas were going to compress over time. So we suggested building them just a little bit higher, knowing that you'd lose like a certain percentage of mounded earth over time. But here you can see that kind of like spectrum of new SAV habitat all the way up, and kind of like thinking through this upland transition, and then a little bit of woodiness in the tips of those new burns. And the hope is that these new slopes would create a more diverse habitat for waterfowl that the refuge is trying to support. And this is where that community engagement kind of really kicked in. But we were designing slopes that were specific to those kind of questions that we were asking the birds, making sure that they would enjoy these new places. These new features also echo familiar places that the island knows and the sound encompasses. So we made sure that the scale and the slope of these areas were known not only to the bird species, but to the place itself, to the sediment and the geomorphology of the surrounding area. And while there actually is a bit of hesitation of putting kind of woody vegetation into a marsh, it kind of already exists on the north and south end of the island. And so we were kind of like taking some of that as precedent for adding these new islands into the core of Mackie. We also found this article that suggested that filling small pools that exist in the marsh is more effective and cost efficient than trying to fill the large ponds. So essentially the small ponds will come together and turn into big ponds quicker than the big ponds will become bigger. And so we found this kind of like mini dredge machine that we suggested that they get to fill the small ponds using sediment from the kind of like existing channels marsh. There's also a new method the refuges in the Northeast are using for drainage called runnels. And these small indentations in the marsh connect larger pools with existing channels to allow for better surface drainage, especially in these kind of like microtidal environments. So we kind of like mapped out like the larger ponds that could kind of connect to existing channels that would be kind of good to do or use this method. And for the south bays, we suggested similar installations as the north end. So again, using this like brushwood method, but for bank erosion. And so these fences actually run kind of like parallel to the refuge road and help hold sediment in. The refuge road is this like white line. This is a interior of an impoundment, and this is another impoundment here. And this is kind of like open bay. And so these shorelines are kind of like very slowly eroding because they're peat, so they kind of like calve off in chunks. But just trying to kind of like think about how to hold in some sediment along there. And so these brushwood fences would kind of like tie into the shore at both ends, hoping to hold some of that sediment. The ones on the north end are open on one end, so they still allow for like some water flow, but these are closed. The brushwood fences, I will note, have this kind of like opening every, this one's about like halfway along the whole thing. And that's just to kind of like let water out or sediment out, but it's just in line with the precedents that we were studying from the Netherlands. So this is our best guess at the hydrology of the island today, which funnels water through Corey's Ditch, which again is this like big thing here, and consists of several dead ends, which create those large pools and result in the drowning areas of the marsh. And the roads exaggerate this issue by cutting off connections that would allow water to move north and south along the Sound's natural axis. So the proposed idea encourages kind of a more dynamic water movement through the marsh during large storm events, but also kind of creates like a bit of separation on the day-to-day. And essentially the refuge staff asked for kind of a vision for the future that takes into consideration these challenges and dynamics that surround this particular place. And while they may not be ready to kind of implement a berm around the pools today, it does give them the opportunity that when like Ducks Unlimited or the Corps reaches out with like sediment or funds, for them to be able to kind of like present data and resources and ideas rather than just letting opportunities go. And so this careful approach takes time and a bit of patience. And as in any kind of design process, we spend a lot of time coming up with bad ideas or drawing things that make no sense. This is actually the frag drawing is like this like series here, which is funny. But ultimately, it's in the service of finding a few interesting suggestions or ways of working that are kind of new, hopefully. So that's all I've got. Thanks for listening. I'm sorry I'm not there. I feel like we'd have a lot more fun if I was in the room, but I really appreciate it. And I'm happy to answer any questions. We can talk about this project or projects that we've got coming up, process. If you want to talk about how to put a rhino model in CMS, we can talk about that. But let me have it. Thanks.
Floor is yours, folks.
I have a question.
Sure.
I saw that you have a focus area down towards like Oregon. Like, could you speak a little bit towards that side?
Oh, P Island. Yeah, P Island is interesting. What about the inlet are you interested in? I'm curious.
I have a senior thesis project in Nags Head, now in North Carolina. So that's just kind of like directionally where I'm looking at. So.
Yeah. So the P Island project was fascinating. So most of our work, at least on the Tidelands side, is like estuary and bay focused. It's not like open coast focused, but P Island kind of scratched the edge of the coast a little bit for us. And so in that one, we were studying kind of like barrier island movement and like dunes. And especially along the North Carolina coast, there's like so much that's like, there's so much built infrastructure that's kind of like keeping the islands static when all they want to do is move. And so our kind of like proposal, at least like for P, was to maybe let some of those processes happen, but rather than be completely destructive, like maybe there's a way to kind of choreograph sand movement that's already happening, and just maybe putting it in a different place than they're putting it now. And so that's mainly what that project was. There's also like quite a bit of like shrinking marsh that's happening on the bay side of those barrier islands. And so it was like also a bit of a study in kind of like how can we encourage maybe some of that sediment that's being pushed to the east side, maybe like push it to the west, or let it kind of like transfer through some sort of like wind tunnels through obviously like aeolian transports happening, and encourage some sediment to come back into that like backside marsh habitat. So yeah, it's a fascinating and strange place. We also did a pretty in-depth study of the shoals that are happening like in that inlet to understand if there's like a way, there's like quite a bit of dredging obviously that happens like in that inlet because it's the only one along that stretch. So we also looked at kind of strategic placement of dredge material, but in order to do that, kind of had to study the existing kind of landscape forms in that area, which are the shoals. So yeah, I'm not sure if any of that sounded fascinating. I'm happy to elaborate, but sounds like a Nag's Head is a cool place.
Sure, for sure. Thank you.
There's these like dune forms. I don't know if you've come across them called Madonnas. If you're, yeah, they're like very specific to the North Carolina dune systems. But they're, anyway, it's just, it might be an interesting tip off if you're looking at that area. They're like a unique landform for that spot.
I have a question about the last project.
Mhm.
I know it's very close to an agricultural area. Was there any challenges with things such as runoff, or like how did that affect the design process?
A little bit. So the agricultural community, I guess I'll go back. Let's see if I can. So the agriculture, you're talking about like kind of this end of the island.
Yes. Yeah.
It's really strange. Like if you look at the slope of this island or the contours, this ridge here, which you can see with all the like kind of trees and stuff, is about 9 feet high, which is kind of crazy for this environment. But it acts as like a bit of a I don't know. It's got its own. Each side is kind of separate because of that like ridge line, and so we on Mackey were not really concerned too much with like the agriculture that was happening along this side because the watershed is going this way. We think maybe some pieces of it were coming in here, but it was difficult to kind of understand. But in the large scheme of things, we kind of looked at them as like separate pieces. There was like the other project, the one on Alligator River, was looking very specifically at like agricultural practices. And I'm happy to share that report out if you're interested in kind of the dynamics of some of that.
Thank you.
Sure.
I've got a question.
Cool. Can you guys say like your name before you ask the question, just so I have like a person to respond to?
See, this is Pat.
Hi, Pat.
What did you learn from testing your designs in your laboratory space?
Ooh, physical modeling or digital modeling?
Physical model.
Oh, so much and not enough. The limitations of physical modeling are quite frustrating sometimes. And I think we learned very quickly that this project was going to need to model fine sediment in a way that we weren't going to be able to like recreate quickly enough, or we couldn't really find a solution to model fine sediment. We had kind of like looked at using, actually in that video, sorry, it's going to be dizzy here for a minute, but in that video of my colleague kind of like dumping things in that basin, let's see, those are like little walnut shell, like crushed up like walnut shells. And we were like hoping that that was going to be kind of a proxy for fine sediment, but it didn't totally work out right. And so I think mainly here, what we learned was more process based than it was like project based. I think for the project based things, we felt that the digital modeling was going to be more helpful in this. And that's unfortunately sometimes the case, is you kind of like try this thing and it works in some way, but maybe doesn't tell you a lot. So I hate to disappoint you, but we didn't really learn too much about this specific question as like a design method. I think there were some other tests that we wanted to do, but kind of ran out of time a little bit in terms of like the porosity of the fence. And so we ended up going in, we have like a geomorphology table as well. So this is like the big basin, and then we have like a smaller table in the school that we can use kind of like finer sediments or sediments at different scales. And so we did go in and kind of like play a little bit in there, but we're still tweaking, I guess, or trying to figure out how to model that like fine grain stuff. It's tricky. We're thinking maybe about using dyes. It's maybe more about like something we put in the water, and the water can kind of like tell us like where things might go. But I'll keep you posted.
Thanks.
Sure. Thanks, Pat. Can I actually ask you guys a question?
Go for it.
Great. What is the kind of like attitude towards like this modeling type of thing? Do you guys do a lot of physical modeling, or are you interested in kind of doing some of that like hydrodynamic modeling? Like, is that something that you find could be helpful for your work?
Yes.
No is a good answer as well. I just want to know why. And yes is also good. Why yes or why no?
I think that a lot of our model making in school usually deals with like stagnant models that are just like how something looks. They don't really deal with like dynamic forces of nature, like something like this. So that's why something
Okay.
like this is interesting.
That's like it's a difficult thing to try and figure out. Those dynamics are kind of a mystery, for sure, unless you kind of get your hands dirty. But a beautiful model is always good too.
I have a question. Hello, my name is Vincenzo, and I'm a visiting professor here. And first of all, let me do congratulations to you for this work. It's very interesting, and it's a very good example for the students to understand how to connect the geographic scale with small intervention and look at the strategies that you may use.
Thank you.
That's very interesting. So one question I have is concerning the use of your kind of devices that you now are introducing, the new tools for the design. Were you able to test the outcomes of their application?
Are you thinking the brush fences?
Exact. For example, that one.
Yes, we're kind of like testing as we go a little bit. So it's like a combination of like the modeling that we did, as well as like the precedent studies and things like that, and then the thing that Fred kind of built. And we're like actively kind of like watching this happen and trying to figure out like ways that we would change it in the future. One of those things is making it taller. And so this fence is at kind of, I don't know if you can see, but there's like a very, very slight kind of like change in these different like ranges of marsh. But the fence was kind of built to the lower edge of the marsh platform. And in this photo, you can see it's completely covered as the water, this is like high water. And so we think that it would probably have a quicker change if the fence was built at the kind of higher marsh mark. So where the kind of like woodland transition or the upland transition kind of like starts to happen. And so in the design proposal, that's why we kind of like brought that fence up about 6 inches. Rather than having it at this like low mark. So I don't know if that answers your question totally, but we are kind of like making adjustments based on kind of like this piece that's already out there. There's also some like questions about maintenance and things like that. Like we check, or I was out there with Fred about a month ago. And, we checked the integrity of the fence. Is the brushwood still there? Like, are there pieces that are rusted? Do the fence posts feel like they're still stable? So there's like a lot of data that we're gathering about the kind of prototype, I guess, that's out there.
We might have to call that for the day, but let's give Ruby a bigger round of applause.
I'll be a floating head again here.
On the studio, I guess. Thank you,
Thank
Ruby.
you guys so much. Good luck with your final projects. Cool.
Thank you, Ruby. That was fantastic.
Thanks. I'll look for